Hello everyone. SIUK India is live with Liverpool Hope University. Thanks for joining us today. We have Professor Atulya and Charlotte with us today. Over to you, Professor Atulya. Professor, you are on mute. Could you please unmute your mic?
Is that better? Can you hear me now?
Perfect.
Okay, thank you. Thanks very much, Deepika. And welcome to you all. I don't see you on my screen, but can I start by wishing you all namaskar or namaste? And today is a big festival in India. So Shubh Ram Navami to you all, those of you who are celebrating Ram Navami. Of course, these are difficult times, and I speak to you here from the United Kingdom, UK, Liverpool, via this digital medium. This is what the pandemic has done to us. I would have loved to be in India, as I do when I get a chance. I actually visit and speak to young students to advise them on various aspects of their career development. But I'm sure this too will pass, and we will have an opportunity to meet soon. I'm of course aware of the severity of the pandemic in India. My own parents and friends and family members are there. So perhaps I should start by saying to you that please do be safe, and I hope that everything goes well. To start with, let me very briefly introduce myself to you. I'm Atulya Nagar, and currently I am the Pro Vice Chancellor responsible for research at this university. I'm a professor of mathematics. That's my training. I grew up in the northwest part of India, in the state of Rajasthan, a place called Ajmer. Many of you will be aware of Ajmer. Ajmer is a very important city in the state of Rajasthan, very famous for Khwaja Moinuddin Chishti's shrine, Dargah, and of course the Tirthraj Pushkar. So that's where I grew up. I went to St. Anselm's School. If there is anybody from Ajmer, then you will recognize that school, a Roman Catholic school, very multi-religious, kind of faith-based upbringing. I was very privileged. So I did my education back there in India, my schooling, my university education, master's in mathematics, undergraduate degree in mathematics, MPhil, and then I was awarded a very prestigious Commonwealth Fellowship to come to the UK in 1993 to do my PhD from the University of York. So that's the DPhil that I have from the University of York on the screen, as you see. It's the Doctor of Philosophy. And then I actually went back to India. I actually came back to serve our country. I worked for Indian Institute of Sciences in Bangalore and IITs, Tata Institute of Fundamental Research, very small kind of durations of projects at these places. And then I was again back in the UK at Brunel University as a research scientist, as a research fellow. And in 2001, I moved to this university, Liverpool Hope University, as a very junior member of staff. And I then rose up in the ranks. I became a senior lecturer and associate professor, which is, a stage before you become a full professor. And I created a department with my own hands. Very privileged and very delighted really to talk about the department that I have created with my own hands at this university and some of the courses. So that's me, that's my background, my introduction. It's a lovely university. I'm very proud of this place. The topic today is prospects and possibilities in the area of artificial intelligence, big data, and robotics. And then I actually do want to give you a little taster of things. I could have actually posed this question: what are the prospects and possibilities in these areas? I mean, that's the question, the underlying question in this title. And if I want to give you a very, very brief and quick answer, then I will say that challenges are many. And when I talk about challenges, I mean challenges in good way, in good sense. You know, I mean, when there are challenges, then there are opportunities. There are problem-solving opportunities. So there are many challenges in a good sense, in a good way, and thus there are many opportunities. And that's a great and exciting thing. I hope you see that. AI, I will show you on in my next slides. AI has a long and rich history, starting in 1950s with the seminal work of Alan Turing. Some of you will be familiar with Alan Turing. Right here in the northwest of England, where we are, this university is actually, Alan Turing was not far from here. He was at Manchester. Manchester is not very far from Liverpool. The famous Alan Turing test, if some of you have read about it in your engineering, undergraduate engineering courses, the famous Turing Church theorem and so on. And really what Alan Turing did, he actually posed the question, can machines think? Can machines be intelligent? That's what Alan Turing did. By the way, we all have computers. We all use these computers. In fact, we have computers in the palm of our hand, these mobile phones and so on. But the first computer was not a physical computer. It was actually a mathematical concept, a mathematical computer. That is what the Turing the Turing test is: a conceptual, mathematical, conceptual model before the physical computers arrived. So in that sense, artificial intelligence is not new. It has been there. If you look at the historical account, and let me remind you a few things. Some of you will remember the Deep Blue computer and the chess game between Deep Blue and Garry Kasparov. And of course, there are numerous examples which I can easily list. With the excitement of AI, there has also been hype around AI. So if you go back to 1950s, and you will find many interesting futuristic talks about artificial intelligence. Some of these things have become a reality now. The Zoom that we are using, by the way, has underlying algorithms which are based on mathematical concepts like the cosine transformation. And look, in 1950s, you wouldn't have thought that one day you will be able to attend a seminar, I will be able to deliver a talk to you, and so on. I think there is a lot, and history sometimes is a very good thing to read, whether it is artificial intelligence history or history of mathematics or history of computer science, for that matter, any discipline. History teaches us quite a lot. So if you want to really appreciate the subject area, read its history. Now, AI is actually everywhere. And when I say everywhere, I really mean everywhere. Pick up a newspaper, pick up a mainstream newspaper, and you will find debate on AI. And you will find pros and you will find cons, advantages, disadvantages, scare stories, exciting stories, innovations, all sorts of things. Of course, there are some who believe that AI will end the world, AI will result into job losses. Some of us believe that those are not the real challenges, really. There are, of course, all these topics, by the way, are worth debating. I'm not saying that we shouldn't talk about these things. All these things, pros and cons, ethics of AI, all these things are very important. We must debate these things. Obviously, in this session, I'm not going to go into those things. There is a whole area of intelligence and consciousness, and the debate of AI and consciousness, and and so on and so forth. I'm a mathematician. I think, as I mentioned at the beginning, I am very keen on mathematically modeling concepts and ideas out of my passion as an Indian who has studied the Vedic literature. I haven't published anything yet, but I have been modeling some of the Vedic concepts using mathematical language. That's mathematical modeling. But that's another thing. That's a topic for another day. The challenges in artificial intelligence are grand challenges, really, of environment, health, and the recent pandemic, if anything, has shown us that. Good example, a lot of genomics is done using artificial intelligence, very sophisticated computational tools. The challenges of economy, challenges of poverty, etc. Those are the kinds of grand challenges that we need to solve, and artificial intelligence can help us there. Of course, there are ethical considerations, and so on and so forth. AI has had its ups and downs. The Lightle report in 1973 led to AI research being cancelled, resulting into AI winter. By the time, as you can see on this graph as well, 1990s rolled around, artificial intelligence became a dirty word. Of course, at the same time, and despite all the bad connotations, all the bad names, we saw things like washing machines, dishwashers, rice cookers. Many of these things use sophisticated computational algorithms. One particular algorithm that I want to mention is fuzzy logic. Fuzzy logic is the logic of the fuzzy. The logic itself is not fuzzy. It's a very mathematical theory. It was, of course, the father of fuzzy logic is late Professor Loftai-Zadeh. He did a lot of work, but when he produced the theory of fuzzy logic, it was rubbished. And then, while he was working with some Japanese collaborators, a raft of new instruments, machines started to come out, and washing machine and photostat copier and all these things are very good examples where fuzzy logic is utilized. The AI winter continued until the year 2000, really. I was, as I mentioned, researching in the area of mathematics. I was just about moving to this institution. Perhaps many of you were not born, or maybe you were very little. It was widely accepted that AI won't work. AI will just not work. That's what people thought. AI then became an underground activity, and researchers would use terms like search algorithms, you know, um, business rule engines. These are the terms that were used instead of artificial intelligence. Algorithms, simply algorithms. Constraint solvers was another one. Constraint solvers, solving the problem in the presence of constraints or conditions. Operations research, a very important discipline. Actually, it emerged from World War II. Danzy and others, mathematicians in the US, were commissioned by the US government to help organize the logistics of the war. And from that emerged this whole area of operations research, which is a very, very active research area nowadays. But then in 2010, the winter seemed to be over. Mainly because of the advent of powerful computers, machines, a perfect storm of powerful GPUs, the graphical processing units, thanks to computer gamers, of course, and huge amounts of data to fuel these GPUs with, thanks to Facebook and all kinds of social media and so on. And really, people started to talk about now. If you look at any government's industrial policy, whether it is Indian government or UK government or Chinese government, for that matter, US government, you will see that artificial intelligence is a very, very important aspect of their strategy. In fact, people were talking about in 2019, a couple of years ago, people were talking about the fact that next 5-10 years are going to be AI. This pandemic will accelerate that, if anything. That all the innovations in artificial intelligence will only will only be accelerated. And definitely the next 5 to 10 years are full of excitement. It's like the industrial revolution, the next revolution. I mean, when the electricity was invented, can you imagine how the world transformed? In 80s and 90s, not many people knew about internet, emails, browsers, and now we all use it. It's everywhere. The mobile devices. In a similar manner, artificial intelligence and such will really pick up. It's already happening. Some of us believe that this current health situation will only accelerate the process. Of course, we live in unprecedented times with COVID-19. Health condition and many of the AI techniques, such as deep learning, is already being used. My own research, I'm working with some of my colleagues, even in India, joint collaborative work is on some of these things. But as you know, the applications of deep learning, machine learning in drug repurposing or repositioning, and there are publications, huge amounts of publications already out there. Now, that is all fine. We have been talking about AI. But the thing is, AI is a very vast area. In fact, it's not only a vast area, there are many, many applications. In fact, it is an umbrella term. And all aspects of AI are important. Of course, we can look at the formal definitions and we can go into this, but just very briefly, artificial intelligence is replicating human behavior. That is the main hallmark of intelligence, the artificial intelligence. Now, the mathematical apparatus is very well advanced in the field of artificial intelligence, which is, as I have already said, rapidly developing. The apparatus is very good. I have always believed that you do need good mathematical background in order to do some serious, and of course, programmatic. You must be a good programmer and so on if you want to really do something excellent in this area, something proper. The apparatus is very well advanced. In fact, if at all, the modern computer power has helped the modern mathematics further refine, the way we now do mathematics is quite different from the way we would have done in 70s and 80s and 90s. The entire area is very kind of it's not a crisp set. It's very permeable. So you can use the term inter, multi, intra, trans, whatever. It's a very interdisciplinary area. It's a very interdisciplinary field, and applications are many. Applications in health, applications. COVID is a good example. IoT, driverless cars, automation, industry, manufacturing, you name it. Education, even education. The important thing, in my view, I think this is the take-home message. Define your own niche or trajectory for success, and that's key. That's the important thing. It's such a vast area that you really need to define your own niche. I will show you in the slides further on how some of our students have exactly done that. We give them an opportunity to do this. Of course, the UK higher education system is second to none. It's an excellent system. Many different courses in artificial intelligence, many different titles. In the UK, the master's degree places an emphasis on you becoming a master in your discipline. That's the idea, which means that obviously, even with the best of the will in the world, you cannot study all the areas in artificial intelligence for that matter, or mathematics for that matter. So the idea is that by doing your master's in the United Kingdom, you become self-dependent, a self-learner. So you should be able to pick up something new, and you should be able to have a go at it. That's the idea. That's the master's degree. A very important component of UK masters is a research dissertation, an opportunity for you to do something new, something different, cutting edge, perhaps even publish. Now, of course, I talked about masters. Similar thing applies for undergraduate degrees as well. There is a lot of emphasis in the UK on, of course, there are exams, of course, there are coursework and so coursework projects and so on. But there is an emphasis on the element of research to make you an independent learner. Now, let me talk about courses at this university, Liverpool Hope University. We have a number of courses in artificial intelligence. BSc, of course, is a 3-year degree. MSci, it's a 4-year integrated master's. So we have these in data science, we have in software engineering, in computer science. So these are undergraduate and a 4-year integrated masters. On the master's front, on PGT front, we have MSc in data science, MSc in robotics engineering, and a master's or MSc in advanced computer science. And then we have something called MRes. MRes is a master's by research in the area of robotics. So these master's degree are, MSCs rather, are taught masters. So 120 credit is a taught part and 60 credit is a research dissertation. So that makes 180. The master's degree is 180 credits. 120 is taught, and the remaining 60 credit is a research dissertation. The MRes is a slightly different degree. It has a much bigger proportion of research dissertation. So 150 credit is research dissertation, and the remaining 30 credit is taught. All our courses are computational and mathematically rich. The computational and mathematical richness adds the value. As I've already mentioned, we believe that the courses should be value adding. We do believe that there is the mathematical underpinning, which is important to understand whether or not you are a mathematician. It is very important that mathematical understanding, mathematical grasp is good. Our teaching is research informed. This means that all our academic staff members, and I really mean all, have a doctorate degree. They are at the forefront of their discipline. They are researching. They are at the top of their discipline. They're publishing in top journals, and they are teaching with that background, that experience. At times, they also incorporate their research in the teaching. So for instance, a research dissertation is a very good example where the students get to work with staff members on a joint collaborative research project. Many of these students end up publishing in conferences and journals. I mean, there are examples of students publishing in very good quality journals. Some go on to do doctoral studies, some go into the industry and so on. We, of course, have a vibrant postgraduate research program that is PhDs or Doctor of Philosophy and Master of Philosophy, MPhil, again supervised by leading research experts. Of course, this is the School of Mathematics, Computer Science and Engineering, and we have a mathematics program, an undergraduate BSc, and a 4-year integrated MMath plus MSc in mathematics as well. Our courses are accredited. In fact, we have just been given accreditation by the British Computer Society, the BCS, for our computer science and some of our engineering courses. The accreditation is very important. Accreditation is like an external kite mark. It's a quality assurance. We have just received the BCS accreditation. So I just used their logo, whatever I could find. The advantage of BCS accreditation is that if the student meets the criteria, then they are able to become a chartered engineer, C-Eng. Similarly, the maths courses are accredited by Institute of Mathematics and its applications. And here again, on successful completion, students either become eligible to be a chartered mathematician, or if they do a 4-year course, the integrated MMath, then they actually become a chartered mathematician. So those opportunities are there as well. I think while I'm here, I should just very briefly mention that the courses, I mean, different universities title these courses in different ways. We have, titled the courses AI, software engineering. Of course, there are some commonalities, but there are some distinctiveness amongst these courses as well. When it comes to AI, I've already mentioned it's a very vast area. I've briefly talked about the fact that there are many challenges. And I must also add that if actually you are not there, if you are a computer scientist or a mathematician, if you are not there, you may miss the boat or you may miss the train, because this is where things are going. So it's an important area. The vastness means that we have to cover. We must ensure that the courses are reflective of the current state of the art. The state of the art is things like fuzzy logic or fuzzy systems, evolutionary computing, systems inspired by biological systems, swarm intelligence, probabilistic systems, evolutionary robotics, vision systems, etc. Of course, you may be aware that whether these days you are a cricket fan or a football fan, all these events make use of virtual reality. Virtual reality is a very rapidly growing area. So is augmented reality. And again, our courses include aspects of virtual and augmented reality. These things are becoming very important, not only in football and games, but in banking and prediction of earthquakes, in stock fluctuations, stock market study, modeling the weather, very, very important. Of course, the Internet of Things and driverless cars. I myself I'm a mathematician. I work in the area of some of these biologically inspired systems. One of the things I do is membrane computing, or P systems, known after a great mathematician called George Pon, who is the father of membrane computing, DNA computing, and I work with a number of my Indian colleagues. And there is a particularly strong group in South India, and Madras Christian College and so on. And that's the group I'm involved in. In North India, you may have come across, there is something called Soft Computing Research Society. Dr. Bansal was supposed to be joining me today. He's from South Asian University. Unfortunately, he is down with COVID. His whole family is infected, and he could not make it. But Dr. Bansal is a close collaborator from South Asian University, and we have this Soft Computing Research Society through which we organize events and conferences for young and upcoming researchers, and of course students. Now, the School of Maths, Computer Science, Engineering, as I mentioned, this is a school that I have created in my own hands. I'm very proud of this. We are one of the top departments or schools for computer science in the UK. We ranked 8th in the country out of 105 places, according to the Guardian League Table 2020. As I mentioned earlier, highly research active and enthusiastic staff members. Students really love working with these colleagues because there is so much to get excited and learn and do. Remember, I mean, degree, it's one thing to get a degree, and there are so many people who will graduate with master's degree. The important thing is, what is different about you? What have you done that makes you employable, unique? And that's what we encourage our students to work with our staff members to identify their niche. We are a small university, small school, which is a benefit, which is an advantage, because there is that sense of community, because we can afford to work very closely, know our students very, very, individually. So we are a student-centered community. We have lovely campus. Unfortunately, you cannot see that. I can perhaps show you the camera later on through my camera. It's a beautiful campus. We have state-of-the-art laboratory equipment. We have 3D printers, different types of robots, virtual reality, augmented reality labs, simulation lab, high-performance computers, and so on. There are numerous success stories of our students. And I always say to the students when they come here that your master's degree is for 1 year. If you're doing undergraduate degree, it's 3 years. If it is integrated master's, it is 4 years. But whatever degree you have come here to do, pay your utmost attention to that, because on successful completion, you will make the most of it. And there are numerous such examples. Those who take my advice, they have really made a good fortune out of their degree. Of course, life will come in your way. Of course, there will be all sorts of temptations, but sometimes you have to give something to gain something. This is a former student who actually came to us, did his PhD with us, really. He came to us from Ethiopia, and he was hired by Facebook to work on their new tactile virtual reality headset. He did his PhD in the area of robotics. Some of the equipment that you see is part of his research. I can give you numerous examples. Another student of ours went on to IBM in California, working on a very large futuristic workspace project. And he has just moved to Google. We have students who work for Oracle, for Barclays, and so on and so forth. Excuse me. Here is another quotation which we just obtained before coming online from one of our Nigerian students who found us, was delighted to come here. As he says, the university's support for international students is top-notch. And he has learned a lot. He is really enjoying his time here. Now, of course, we are an international university, very well connected. I've already mentioned some of my links and connections in India with these IITs. I'm an adjunct professor at IIT Roorkee. Been there, I was on a sabbatical for 3 months at IIT Roorkee in 2013 December. We have just hosted an international event conference at IIT Indore, SOCPROS 2020. We have connections at IIT Mandi. I think this conference is taking place at IIT Mandi next time. Dr. Bansal unfortunately could not make it, but he's a visiting research fellow at this university here, and he's a very close collaborator. We have connections with faith-based institutions in India, Madras Christian College, very kind of top-notch institution, Stella Maris in Chennai, St. Xavier's in Mumbai, Christ University in Bangalore, just to name a few. And of course, outside India, then in Europe, we have connections such as Lille, Catholic University in Lille, at Angers, Hope College, Michigan. Many US universities are our kind of very close partner institutions. The research dissertation is an important one. I've already talked about it. It is one mechanism which actually takes some of our students to international places. Actually, there are stories about Indian students who have done their research and now are successfully employed by multinational companies in India. In fact, one student wrote a book on artificial intelligence after she completed her master's degree. Now, that's all about the university, and I will say a little bit more about the university in a bit. But I did say in my title, it's a taster. So I do want to give you a taster of artificial intelligence. I'm sure you all have seen birds flock. There is a saying, birds of same feather flock together. You've seen the birds flock together, of course. They form a beautiful pattern. If you have seen starling flocking together, they make a nice pattern. Now, obviously, this is the theory of complexity and theory of chaos and complexity. Of course, there is a lot I can talk about. Of course, Stephen Hawking, Professor Hawking, very famously commented that the last century, the 20th century was the century of quantum mechanics, and this century in which we are now, 21st century, is the century of complexity. Now, of course, I can talk about complexity and so on, but this is just a taster. So how do these birds flock together? And I must say they flock together with such a grace. When we human beings find it very difficult, even in these pandemic times, to maintain the social distancing, and we quarrel about all sorts of things. For instance, religious matters and so on and so forth. And these birds are so tolerant and such graceful coordination, as if there is one brain behind that flock, or there is an invisible force at play, as if. But let me tell you, there is no queen, there is no king, there is no leader, there are no blueprints, there are no traffic signs, there is no top-down order. If at all, there is a bottom-up order, not top-down. No leader, no conductor, no director. They organize themselves, they self-organize themselves, and that self-organization comes from bottom up by following three simple rules: separation, alignment, cohesion. This, in mathematically speaking, we call it emergent behavior. So if you took one bird out of that flock, and if you want to understand how they form these beautiful patterns, you won't understand that. You have to take the whole system, the holistic approach, the whole system, if you want to understand the flocking of the birds. They adapt, they have the ability to adapt. And those are the three principles. They use the visual clue, they influence the air current, and they self-organize. As a result, what happens? We see this emergence of a beautiful pattern. This is known as emergent complexity in the theory of complexity. The behavior of the whole is much more than the sum of the individual parts in this case. So the whole is much more than the sum of the individual parts. As I say, you can't just take one starling or one bird out of this flock and try to understand why do they make this beautiful pattern. This is the flag of emergence. This is known as emergence, a very important property of complexity. We can model these behaviors, and actually we do. Some of you, if you have studied in your computer science courses, something called flocking behavior, or the flocking algorithms, or there are many other species that flock. For example, the ant colony optimization algorithms we find in computer science, in artificial intelligence. Ants, again, there is no leader, there is no queen or king. They self-organize. We can talk about the pheromones they use and how they organize themselves. Similarly, termite, I think in Indian Hindi it's called Deemak, termite. And if you travel roadside in India, you will have seen these beautiful castles that are formed by this Deemak, this termite. Again, self-organized, similar kind of principles. So all of these things can be modeled mathematically and computationally, and indeed, we computer scientists model these things to solve difficult, intractable, difficult problems. And the inspiration we get is from nature. So this is a nature-inspired algorithm, an artificial intelligence in action. There is a lot of inspiration to be drawn from such behaviors from nature. Large-scale order from small-scale interactions. And there are many of these things, these neural networks, the genetic algorithms, the way our genetics works. I talked about membrane computing, the area I work in. Membrane computing is inspired by the human biological cell, which is in our body, the way the cell functions, and so on and so forth. Now, as I said, this is just a taster. As part of the taster, I also want to demo you, if I can pull this thing here and move the camera slightly. Remember, the mathematical apparatus is very, very sophisticated, developed, and the systems don't necessarily have to be complex, and we don't necessarily have to design complex systems to solve complex problems. And simple systems can also demonstrate complex behavior. You all have grandfather's clock. You will have seen at home, TikTok, that you've seen it. It's on the wall somewhere, or of course, I don't know how many of us have these things nowadays in the age of digital things. But this is a pendulum, and pendulum, Galileo discovered it many, many years ago. There's nothing uncertain about this. There is no stochasticity here. It's a deterministic system. But what I've done is I have two pendulums. I haven't done it. I have one which I did. This is from Institute of Mathematics, has been gifted to us. So there is one pendulum. There is another one here with a little kind of a joint, a screw. And if I give it a vigorous motion, you will see that this will display a chaotic behavior. Each time you do that, it will display a chaotic, uncertain behavior and follow a different path. In fact, if you take two of these in vacuum, in the laboratory, release these with the same initial conditions, and for a while, they will follow the same path. At certain point, these will diverge and go their own way. So I mean, of course, it's just a very quick taster to say that the artificial intelligence is a vast area, and it's about thinking creatively out of the box. And it is the area to be in, robotics, artificial intelligence, very vast area. But you need to choose, you need to decide what you want to do. Even after you have decided your course, the important thing is, what are you going to do as part of your own contribution, if you like. And research dissertation is an example. This is a PhD project. We are working with an aerospace company. I won't go into too much details here, but here we are using the flocking, algorithm. And the idea here is to HAPS. HAPS are high altitude platform systems. So these are unmanned aerial vehicles. They fly at a certain height above where the commercial aircraft flies. And the idea is how do you reach out? The challenge here is, I talked about the grand challenges. The challenge here is, how do you reach out to more than 2 billion people in the world who actually don't have internet connections? And of course, there are other applications of this HAPS. For instance, reaching out to disaster zones, earthquake or volcanoes and so on and so forth. How do you reach out to those kind of places safely? So how do you put those drones in the air so that they are self-organized, ideally solar powered, self-organized? They constantly provide that communication on the ground. Of course, they can be military applications and so on. But this particular application we have been working on with an aerospace company is actually for internet connectivity to areas where at the moment there is no internet. So there are other research areas in the university or colleagues are working on. HAPS, I already mentioned. We have robotics, applications to medicine, Internet of Things, IoTs, Internet of Medical Things, for instance, spatial computing, artificial intelligence, virtual reality, mathematical modeling of different things, brain processes, human cognition, the cognition of sight or eyes, and so on and so forth. So let me talk finally, before I finish, about the university. I've already mentioned it's a beautiful campus. We are a place where we pride ourselves for academic excellence. We are a gold university for our TEF, teaching excellence framework. We have a gold. We are part of a very small club of universities who have this gold award. Our students rank us very highly. It's a friendly, nice campus located in a leafy suburb of Liverpool, a really beautiful place. We are, of course, a faith-based, Christian faith-based university. Our traditions and values go back to 1844. We are highly research active. We do very well. We are fourth in the research intensity in the Northwest. In fact, in 2019, just a couple of years ago, we celebrated our 175th anniversary. We often call ourselves a very old new university. The campus is it's like a mini township, really. A real collegium where we talk to each other. We are not a virtual community. Of course, this pandemic has forced us to work in using the online medium, but that's not what we are. We want students to be here. We want students to attend our courses. We want real engagement, not a virtual one. This is a picture of the campus, actually creative campus. So we have two lovely campuses, actually 4 campuses, but this is another campus where teaching takes place for creative performing arts. There's a picture of Liverpool City waterfront. Let me very quickly show you. I won't show you the whole video. If I can make it start. Sorry, I can't start the videos. I will probably skip this. Liverpool is a wonderful place. I arrived here in 2001, and I have fallen in love with this place. It's a really beautiful. It's a student city, really, with more than 50,000 students. It's affordable. London can be very expensive sometimes. It is a safe city, and Liverpool is also UNESCO heritage a site. It's a music city, and not very far from London. You just in just over 2 hours, you can go to London if you want to visit. At the moment, there is no travel, of course. A really wonderful place. Let me see if this video can start. For some reason, my videos are not working. But anyway, this is where we are on the map. So if you can see the map of United Kingdom, and that red dot is where Liverpool is, and Manchester is also listed. So as I was saying, in the northwest, not very far from Manchester, which is a major industrial town in the UK. You see if this one works, or maybe I need to get rid of. Anyway, it's fine. It's nothing, the videos, but just to show you. Let me see if I can start this video and demo you. The last video, I think this is the important one. I just want to see if I can play this, because this was done by one of our colleagues for the Liverpool City region. Yes.
Part of the reasons why we teach virtual and augmented reality is the coding ability. It's a different type of coding. And the reason why we're using this as a vehicle to teach augmented and virtual reality is because it's the next big thing. It's not just games. What we've tried to illustrate with a lot of our course material that we produced is not only games. It could be medical to help or to simulate some type of medical condition. It could be virtual tourism. It could be virtual field trip. It could be simulations. Learning how to make apps for AR, and not just how to make the apps, the principles of how that works as well, because it's a different type of program. It's not just programming with a keyboard and a screen. It's about programming for the sort of wider world to use real world objects as controllers in the virtual world.
From like the year 3 now, they're teaching them coding and everything like that, because it's considered as important as a modern foreign languages are, and everything uses computers. You go to the supermarket and use the self-service, everyone has a mobile phone. So getting young people into knowing how computers work enables them to then develop technology and gets us new technologies.
When you think of computer science, most people think of the technical side of just building computers and networks and things like that. But although that's part of it, isn't all of it. And it's also very creative, so you can make things, you can create things that no one's done before. So I think if you look at the creativity more and about making things, that will get more girls in.
There's lots and lots of different
I hope you were able to see at least part of that video. I'm just conscious of time, so I've stopped it. I think the video is there somewhere on our website, so you're very welcome to have a look at this video, which really was done by one of our colleague in the school, and it talks about all the kind of things we are doing in the school, and the students, the way the students are engaged and so on. So I think I perhaps will end with this last slide by saying that it's a wonderful place, Liverpool, and excellent university, known for all those things. You can see a photograph of Beatles here, and those, of course, who want to come to us at Liverpool, will be delighted to welcome you. I think I will perhaps stop here. Deepika, is that all right?
Yes, yes. Professor, for your knowledge. We have quite a few questions in YouTube live chat box.
Yeah.
So the first student wants to ask, do you have any one-year data science course with placement?
The one-year course is the master's course. The MSc is a one-year course. As I mentioned earlier, a master's degree is 180 credits. 20 credits of that is taught part, and the 60 credit is a research dissertation. Now, as such, industrial placement is not part of that master's. However, there is nothing, and we have at least a few examples I can give. We do have examples of students who have identified an industrial partner, and they have worked on a research project jointly with the industrial partner and our academic staff members. So I would not say that it's a one-year degree with placement in industry. That's not what we have, because 1 year is a very short degree. It's very hard to pack in all the taught part, the research dissertation, and industrial placement. So no, but there are ways to do that, and the research dissertation, 60 credit dissertation, is a mechanism to do that.
Thank you, Professor. The next question from the student: what are the job opportunities during studies, part-time jobs?
Charlotte may have more answer, but I would, there are opportunities. Students can work, I think, up to 20 hours, not more than that, because the visa rules are important to follow. My advice to students always is, I appreciate that you need to support your maintenance and so on. But as I say, I think the more you spend on your studies and the kind of well you do in it, and the sooner you do, the better is the return. But there are those opportunities. Charlotte, would you please answer?
Yeah, of course. So as you said, Atolia, it is up to 20 hours, and that is the UKVI rules on working while studying. But we do have lots of jobs on campus, so we love students getting involved in student ambassador roles where they talk to students on our behalf. And we also have other jobs in the catering outlets, or occasionally internships with specific departments themselves. We have a wonderful careers team and an organisation called Hope Works at the university, which can help with part-time jobs while studying. And Liverpool as a city is really tailored towards students. So if you didn't want to work on campus, there's lots of external opportunities in the city as well. Thanks, Deepika.
Thank you.
Thank you, Charlotte. Thank you, Professor Atulia. The next question student wants to ask, do you have information on average earnings post completing your MSc Robotics Engineering?
From the top of my mind, I don't. Charlotte, I don't know whether you would say that, but I know that obviously we don't ask our students how much you are earning. Maybe we do, but we don't ask personally. Salaries are things which are quite personal. But I know that many of our students are very highly placed. Sorry, Charlotte, you go ahead.
I was just going to agree that when the destination leavers survey goes out, the salary earnings aren't specifically a part of that. So as Atoya mentioned before, a lot of our graduates go on to work for high profile countries such as Oracle, such as other big industry leaders. So probably if you're really interested in the kind of earning and career prospects, look on our website at the specific careers that students go on to do, and then investigate those companies and see what those starting salaries are like. That would be my advice.
A lot, by the way, also depends on how well you have done and you know, that's the key. I mean, I can give you an example of that gentleman I showed you on the screen who came to us from Ethiopia. He went to Oculus. Oculus were paying him $9,000 per month. First, when I heard that, I could not believe myself. I thought must be per annum, per month, plus house rent allowance and all sorts of things, because he was so sought after. So in this area, you really need to be very good and sought after. And there are ways to do it. It's hard work. So obviously, as Charlotte says, we do have a survey destination levers. As part of that, these things are done, but we would not have on our fingertips the salary or average salaries. But I would imagine good starting salaries. This is an area which kind of, if you are very good at it, then you do get rewarded very well.
Thank you, Professor. The next question, the student wants to know, are you hosting career days during data science MSc program?
Yeah, so we do when students are on campus, obviously not currently, we do, our careers team hosts industry days, career days, and normally they will get a number of organisations, employers into the university, and students it's like a careers fair, students can go to that at their leisure and talk to these organisations. Again, I can't say for sure that would run next year, but that has been something that has been a prominent part of the university life whilst I've been there. So, the careers team do run opportunities such as that. Apologies.
Mm-hmm.
Thank you, Charlotte. The next question. Hi, can you tell me about September intake deadlines?
Yeah, of course. So we are still open and accepting applications for this September. There is no specific deadline that we set. However, obviously due to the pandemic and to visa processing times being slightly delayed, I would highly recommend anyone looking to apply applies as soon as possible. You just submit an application form to our admissions team. That goes off to Professor Atulya's department to review, and then we will be in touch with you regarding the outcome as soon as possible after that. So sometimes these processing times can take a little bit of time, but specifically due to the global situation that we're in, I would really advise students apply as soon as possible so we can help guide you through that visa process and ultimately hope to have face-to-face teaching in September.
Thank you, Charlotte. The next question. I will complete my bachelor's in mathematics this year from Delhi University. When can I apply for a master's course?
So that student can apply now. The applications are open for September 2021. You don't have to have completed your master's programme before you apply, but obviously your offer would be conditional on receiving those results. So students are welcome to apply without their final degree results, but obviously we can't give an unconditional offer or anything like that until we have those results sent in to us.
And we have two entry points, September entry and a January entry.
Yeah.
Thank you. The last question. I had science subjects in 12th. Can I apply for artificial intelligence BSc honors? What IELTS score I required?
Yeah, so that is great. We're really excited that someone also wants to look at our undergraduate course. So we would be asking for around 75% average in your grade 12 overall. And that can be the CBSE, whatever the Indian curriculum is that you're studying. And then for IELTS, it's 6.0 overall. We need a 6 in reading and writing and no individual score lower than 5.5. I always recommend if students have any doubts over, for example, the specific science subjects, or if they've done enough in maths, send in your transcripts to us here at the university. Our admissions team is really happy to look at them on a case by case. And you need to apply to UCAS, so we will review all those qualifications throughout that UCAS cycle. But any doubt, just get in touch with us. Thank you.
Thank you, Charlotte. Thank you, Professor Atulya. So we are at the end of this seminar. If you would like to put something forward for the students who are watching us now.
Well, I would just say thank you for your time this afternoon. It is afternoon in India. We, of course, appreciate that. If you do have questions and queries, you can get in touch with us. I wish you all the very best in whatever you do. And do take care and follow the rules for COVID.
Thank you
Charlotte?
so much. Yeah,
Charlotte?
Charlotte.
Yeah, so I was just going to say thank you to Atulya for hosting this seminar today, and SIUK for all your help and promotion. I've put our contact details into the YouTube live chat, so for anyone watching, please do use that email address, and thank you for joining us today.
Thank you so much both for joining us today. Thank you so much for your time. And to all the students who are watching us now, please feel free to contact SIUK or to Charlotte for any query you want to ask. Thank you so much, everyone. Thank you so much. Bye-bye. Yeah. Yes.
Thank you to you, SIUK, of course. Thanks for organizing this event. Obviously, we don't see all our participants in this medium, but at some point it will be excellent when it is possible to visit and do some of these things face to face. But thank you to SIUK as well for putting this successful event.
Thank you so much. Bye.
Take care. Bye-bye. Thanks, Charlotte. Thanks very much.
Thanks.